The water is for us or no?
Yes, it's for us.
Prova? Sì.
Hello and good evening. We are Studio AATB, and we are here at the Circolo del Design to talk a bit about our work. So we thank you very much for joining tonight. This is Andrea Anner, AA, and I'm Thibaut Brevet, TB. I think, can we have the slides? Yeah, super. So we are here and giving this talk also while we are in the Fab Lab Torino giving a workshop. So if not everybody here knows, we are giving a workshop around robotics and teaching people to use industrial robots to do funny things. So that's also why we are here. So our studio started about 11 years ago when we met while we were studying design at ECAL in Switzerland, Lausanne. And essentially what we started to do was to build our own tools. That was a bit a way of escaping graphic design and not just become a user of the frameworks that were already existing, but an active participant and an active creator of this framework. So what we started to do, because we were studying graphic design, was to build printing machines. And so that's a bit the kind of machines we started to build. That was also a point in time where Arduino started to become very emerging out of a niche. We started using Arduino around 2008. And that was also the trigger that allowed us to reclaim technology that we used in our work. So we started building these sort of printers. For example, here it was a carbon copy paper printer. So we could use carbon copy paper, but we could use it in a digital way. So we could start to use black and white images, but then print them out with this sort of technique that just didn't exist. And so we knew that the quality was not as good as something that you could buy with an inkjet or a laser. But the point was not to do something very precisely. It was to control the whole process, like control and understand the whole process, from the software that you use down to the last bits and pieces of the machine. We were in control of the whole process and nobody else was dictating how it worked. So we could modify it and we could intervene in the way things worked. And so that gave us a very different perspective on what we could design and on what we were able to do as designers. So this is why we were still studying. So as we went on, our machines became more and more precise and evolved and complex. I will just let it finish so you can see the actual print, which is relatively bad, let's say. But what is interesting is that it's a print that came out of like literally hot glue gun and tape, and still it worked surprisingly well. Just a second. So this for us was really the start, like really how we got to this point explains why we are now having 4 industrial robots in our studio. It's a long line of development, but this is the reason. So our machines became more and more complicated as we went on. We started to master programming, we started to master CNC machines, we started to master electronics. We started to learn a lot of different topics that brought us to being able to wire a lot of things together. First of all, this was our graduation project, it was called Grand Central, and it was an online printer. So people on the website could leave messages, and then the machine was connected to this website, and all the messages were printed out in real time. So people in exhibitions could send a message on their phone, and then suddenly would come out in front of them. It was quite interesting because this was 2 years before the huge peak of the Internet of Things, let's say, hype. And so we were already very interested in the possibility with Arduino to connect things online, and what it meant to have a physical object that could have as an input some digital information. And this is also something that became very interesting, and for us, a central part of our research is how do we visualize and how do we experience digital information. So that was a bit how we started. We started also to develop further this project. So this project became larger machines sometimes, smaller machines sometimes. So this is kind of always the same printer. It's just kind of scaled up, scaled down with different printing techniques. And this is also what is interesting for us, is that when you control the production process, you can modify the production process, because you have all the files, you have all the manufacturing details, and so it's very easy to make it bigger or small. This was the Biennale in Venice, for example. It's just 18 printers at the top, and that was essentially printing out the discussions of a symposium while it was happening. So yeah, this started from the very crappy printer done in our room to being this kind of 18-meter long printer. And this is something also that became very interesting for us, is how small projects can develop and kind of outgrow our practice. And so this is a bit how we fell into robots. So this was 5 years ago.
Yes, so 5 years ago, we attended this conference in Basel that was on robotics for architects and how architects could use robots in their practice. And when Thibaut got home from this conference, he only had one thing in mind, like buying a robot. And when he has something in his mind, it's very different to get it out of his mind. So he ended up like scrolling like Craigslist and eBay Kleinanzeigen and all these kind of secondhand market for robots. And interestingly, there is a secondhand market robot. And so we, after not so long of searching, we actually found a robot. And we bought a robot. And that was really the beginning of AATB. So we literally bought this robot without ever having kind of used one ourselves, except at this conference. So, but then we spent kind of like nights on YouTube and really like tried to figure out how to turn it on and how to make it work. We then we got it delivered directly to a workshop. So we had about 1 week to figure out really how to make it work. So so that was really the moment where we started our studio, AATB, that we call a practice for non-industrial robotics. What we mean by that is that we really use industrial robotic arm, but we use them in creative applications. So we we do creative things with industrial robots. So basically, this is 1 week after we have purchased this robot. We gave a workshop at ECAL where we have both studied at the Master of Type Design, and we created a software in which students could draw typefaces or letter forms, and then they could kind of like with this hot wire technique and the robot, they could kind of cut into the styrofoam. It was kind of quite interesting because that's how it looked for them. So they had kind of like a very bare bone interface where they could basically add points and they could select the angles and the depth of the cutting path. And then that's how it looked when it was cut with the robot. This was really, in a way, interesting because it had kind of like you had to be kind of like imaginative how the outcome would look, but also in a way for us it was interesting because we kind of built this safe sandbox in which the students could safely play or interact with the robot, and we with the software were limiting all risks that could potentially happen. So that's the outcome of 1 week of workshop with the type design students. Not so long after this, we got contacted by a Swiss artist, and he was working back then on a project. He wanted to produce drawings for a concrete, like basically in Switzerland, like they spend 1% of new buildings on artworks. So he was doing an artwork in the staircase of a hospital in St. Gallen, and he wanted to have some drawings. And after having seen the results of our workshop, he contacted us. And so we helped him develop the molds that then would serve to make the molds for the concrete castings. And that's some first test. I think the hospital will only open in 2027, so we'll have to wait a bit more for the final results. This is another project that we also, with a bit of a similar technique, but also adapted. It's not a hot, it's not cutting in styrofoam, but like melting styrofoam away. And also this is an interesting thing that once we have finished the project, as we have built all the software and hardware ourselves, for us it's pretty easy to, or like quite easy to adapt the project and to just like we change the tool and we change some parameters and then a new project can emerge. This is a collaboration with a designer, a friend of us, Lukas Uhlmann, and it was a production for an exhibition in a gallery, in a small gallery in Bern, where we actually filled the space of the gallery with these styrofoam blocks. I mean, the project really was, we were interested in like archaeology and the fact that in archaeology, like ancient cultures often tend to use remains of other cultures buildings. So in a way, you have sometimes layers of information on top of each other, and that's what we wanted to recreate in this installation. So we completely kind of covered the space inside and outside.
And then about 5 years ago, we got asked to become designers in residence at the Luma Foundation in Arles. This is in the south of France, about 1 hour of Marseille. And so that was also an interesting development for our studio because that was something called Atelier Luma. That was a bit of a design research center that was really starting. So when we joined the foundation, when it was kind of, we were the first residents to join there. And we've been part of the team there for about 2.5 years. And we had the chance to develop Yeah, and we had the chance to develop a project that has now been nominated for the Swiss Design Awards, but is actually that come just after this one. But this is a printing project that we were commissioned to do for them for the World Economic Forum in Davos. And they asked us to make a very large print out of some of the research that they were doing. So in Arles, it's very close to some salt mines. I don't know how, like where they dry salty water, like seawater, and there's a lot of algae that grow in this salt-rich environment. So they collect a lot of these algae and they grow them and they extract pigments out of these. And they asked us to make this gigantic print with these algae pigments. And so there is no printing technique that exists to print with this. Like you can't just stuff them in inkjet printers because it's clogging the inkjet tip. So we had to develop these printing techniques to print this huge map that was 3 by 7 meters. And so we developed a little software that could allow us to convert this bitmap image that you could see before, and then convert it in tons of points that would fill up these kind of areas of color. And all these dots were then the position of all the dots were sent to a robot that would then deposit a drop of ink in all these places. So in a way, it's kind of like the same process of the very first printer. It's just a source image that then gets converted to be printed by a machine. And so this was just like some early tests where we had the ink that was then deposited. And so it's quite interesting also because when you look at it on a small scale, it's not very interesting, but it's when it starts to grow on a very large scale that it becomes a whole print. And so this was the final map that was segmented in 900 by 600 millimeter segments. So we had to print this map in a lot of different places, and it created the whole structure that was then exhibited for the World Economic Forum. So this is quite something that is interesting for us, is to develop this sort of customized manufacturing processes that are quite experimental, but also the robot brings a lot of flexibility to experiment this, because the interesting fact is that because the robot is kind of a generic programmable machine to move things, you don't have to rebuild a new machine or redesign or re-engineer a new machine every time. You can just program it in a different manner. So at this time, the robot is printing, but then the next time we just change the tool and then we can cut styrofoam, but we didn't have to reinvent a new machine. And this is something that for us was a big trigger to develop a lot of the research, because we didn't have to spend our energy on building machines. We could just customize a machine to do it. So this project, for example, evolved into a different type of project. We were commissioned by the fashion designer Christopher Reburn from London to design a limited collection of t-shirts and garments that were printed with this technique. And we adapted it to use airbrushes this time. So we used some ink, but then we were actually airbrushing it above the fabric. And so we were reusing the software, but then instead of printing physically by touching the fabric, we were hovering above it while printing. And this was it's accelerated. And we printed a limited run of about 50 prints like this. So this is also something that is interesting, is that it's allowing us to have this sort of small scale manufacturing capabilities in the studio. Now we have 2 of these robots, and so we could do 4 layers in about 20 minutes, so per t-shirt. So it's quite interesting that we are able to do things on a medium scale, but then if you would have to go on a bigger scale, then you would use a different technique because it would not be efficient either. So this is something that we are quite interested in, is how robots can, in a way, allow small scale studios, small independent studios to become relevant as manufacturing entities also, and not just having to constantly produce outside or ask other companies to produce because you don't have the manpower or technical infrastructure to do it. So these were just like some of the output. So the second project we did at Luma, maybe you want to, is actually called routing.
Yeah, so routing is a set of tiles that are meant for outdoor flooring, and it's these tiles are basically we got commissioned by the landscape architect that was like conceiving this park that is being built around Luma. And he wanted, so it's Basmet, and he wanted that pathways don't really cut through nature as kind of highway that like cuts through the park, but he wanted to have like tiles that would integrate more like smoothly into nature. So basically, we developed some tiles that are allowing vegetation to grow, and at the same time that support people to walk on. So it sounds a bit abstract because you can't see an image yet, but so basically we were developing some surface pattern for the floor. We're looking into patterns that would emerge in nature, and there is one pretty let's say there is the reaction diffusion algorithm that is defining patterns on animal skins and furs. Basically on all not all, but yeah, on animal pet skin patterns. For instance, on like, let's say leopards or fishes, you can see these patterns. And so basically we're creating a software that is using the same algorithm that is then, so we could basically develop our own patterns. So, so here you see the patterns, and here you see the process of this growing pattern in our software. So basically in our software, you could just like feed some drops, like drop some drops, and then like the pattern would emerge. And so basically, we then turned this pattern into a set of concrete tiles. So here you see every tile. So basically we kind of changed the pattern slightly so that would allow us to create a repeatable pattern. So we have 4 types of patterns. So here you have like, and on the top, like you have like core elements that would go into the center, and then these elements would allow transition towards the edge. So they are half dots and half wiggles, and this diagonal one would allow you to create curves on like pathways, and the other one, like the last one with the dots only, would be on the outside. So this allows you to create really like a kind of like a large pathway that has a transition of dots and wiggles. So basically whatever is color now is then grass, and whatever, like I go back, and whatever is black is concrete. So we also developed the entire like fabrication process. Here you can see a wax mold. So we were CNCing in reusable wax that we were kind of like would allow us to iterate different versions of the design. Basically here also another interesting aspect is that these tiles, they have like little holes on the back. So these dots would then become little holes. And these little holes allow the plants to, the water to drain, and so the plants to grow. And here finally you see like one tile, so still without grass, but then so you plant this on the grass and then you fill it up with soil, and then in this kind of like cavities there is grass that can grow. So here you see a block of these tiles. And here you see it first being laid out. with soil only, and it's a bit of pity because at this moment we did not have any kind of like tests with grass. It's a while ago, but now we actually have some, like, we'll soon show it in a park in Zurich, and then it will be really kind of shown in the grass. Now we have some tests with grass. Yeah, this is this is another project. It was awarded for the Swiss Design Award last year. It's basically a lamp system, a modular lighting system, and I mean, throughout our practice, we also learn how to design PCBs, and this is really quite important because I think often designers don't really know how to design PCBs, and there is always this gap where they use a PCB, but they don't do it themselves. So there are engineers like doing PCBs and then designers using them. So PCBs stands for printed circuit boards. You probably know it from your, I mean, this is only a prototype, so they often look dark green. So that's actually a very first prototype, but the lamp itself, so that's the kind of software we draw the circuit in. So first the diagrams and then the designs of all the elements that go onto the PCBs. And that's actually the lamp as it looks like. So basically, all these PCBs are, so the first PCB is connected to the power, and then the PCB connects through spring contacts. So basically, whenever you screw two PCBs together, they are connected, and so this allows you to create shapes of light. So here there are very simple shapes, but then it also allows you to kind of like draw with light.
Then we are moving into, let's say, the more performative aspect of what we do with robots. We showed a lot of what we do for production and manufacturing and objects, but we've also been very interested in what robots can do as actors, and because a robot in the end is just something that can move. So what we realized over time is that our work was much more closer to a choreographer than just a designer drawing on the computer. And so these are some of the early workshops that we were giving at ECAL, for example, in the interaction design department, where we did something called the Center for Counterproductive Robotics. And so the idea was really to just experiment with everything that doesn't really make sense for a robot if it was used outside of a factory. And so it's also about imagining a potential future or what it could look like, because in a way, like that's the future we are being promised with robots everywhere. But so it's also funny to imagine what it would actually look like. So that's something we kind of like to experiment with, these sort of very short-term workshops where it's very interesting to experiment. And so we also thought about what does it mean for a robot to be able to move things very precisely over time. So we designed this lamp called the Sunny Side Up. And essentially it's a sundial, and it reproduces the exact motion of the sun along the day. So the robot is moving. So here it was shown in Milan, but in a kind of time-lapse version, so we could see something happening. But what is interesting is that it's really mimicking the exact motion of the sun. So the shadow you see is the exact same you would see outside if you would have a sundial outside. And so this is also something we kind of find very interesting, is how technology and how robotics can, in a way, reproduce nature or reenact nature and bring this sort of artificial experience of nature. And so this is some of the experiments we've been trying to do. And this was, for example, shown in Ars Electronica, and this was like 5-story underground in a bunker. And so it was very interesting that you would be so far from nature, so disconnected from the environment, but then somehow you would understand that this is the sun right now, And the fact that you know that this is the sun right now, even if you know it's just a lamp, it's a different experience than just having a stupid lamp that is just in the corner. So this is also something that we like, is how we associate meaning into some completely unrelated in object or a situation, is also something that it's a bit fascinating. Like why is something interesting? Because now we know it means something more than just before, and so that's something we like to play with. This is a project that we did for the Victoria and Albert Museum in Dundee in Scotland. And they commissioned us to make a project that was teasing the Hello Robot exhibition done by Vitra Design Museum. And so this is essentially what you see. It's really like it's called soap opera. And it's just a robot that is blowing bubble all day long and not doing anything else. And so this is something that we found quite interesting, is that in the Dutch paintings of the 16th century, like the Vanitas painting, the children blowing bubble is a symbol used for the uniqueness of human life in a way. It's really seen as the bubble as a metaphor of what makes us unique, because we blow the bubble and the bubble becomes a meaning for life that just stays there for a few minutes and then pops and you're gone. And so the fact that it was seen as just children representing this sort of innocence, but now then done by a robot and done over and over again, almost as if we could think that it's still going to blow bubbles in 1,000 years when there's nobody else, was quite interesting for us to kind of project ourselves. And also because we thought it was interesting what would be the reaction of people, because we expected the project to be much more controversial in a way, like that people would be reacting much more in a nuanced way, because like, oh, like it's you're replacing children with robots. The world was better before, and actually like all the children and everybody was standing and staring at it for hours and just liking it, loving to see it. So it's also interesting that sometimes what we what we think will happen because of robotics is actually not as easy, and so this is something that we think is interesting.
This is a project called Handshake that we developed last year during the pandemic. Basically, we got invited for an exhibition in New York that got cancelled, and were then approached by the curator if we could not come up with a piece that is experienceable from afar. So we came up with this website, Handshake, we could log onto or log into, and then as soon as you're logged, you take control over one of these robots. So both of these robots are kind of controlled by two strangers that are like wherever on the globe, and that are like distant, like they are very far from each other, but that are shaking hand in our studio. So this piece was shown like for 3 weeks, 24/7. And what was really interesting for us also was that in a way, I mean, we could have developed the same as a website, and it would be like would not be the same project, because I think here it was really interesting that this kind of like that these two hands really physically touched, and it was really in a way nice. It was really a manifestation, and for us it was also really nice because they were really installed behind our back, and so we could not really see the hands, but whenever we could kind of like we could hear the hands first, and then we'd kind of log on to the website, and then very often we just like connect with a stranger, and we could always like see from where he was accessing, and it was it was really nice what he created. So then this is a project called Big Player that we have shown also last year in the Zurich School of Arts during a 3 days festival. Basically, it's two robots swinging a rope and allowing people to jump the rope between two robots. Like before developing the project, we were very unsure if it would really work, if people would really jump into, and if it would like, and we were super surprised. I mean, here it's shown empty, but people were kind of queuing to jump, and it was super nice that it was actually it was really working really well, and people. It was super also nice that in a way, like taking off the human factor of like two humans swinging like a rope and replacing it by a robot would actually emphasize more on the human that would kind of like jump, because I think for a human it's different if you jump between two humans or if you jump between two robots. Then if you jump between two robots, you become really the center point, and you can really concentrate on the experience of jumping while the robots just like swing perfectly. And that was super interesting. And then obviously there were some like safety things. As soon as you touch the rope, there was a magnet that popped off. And then as soon as you would like place the magnet again, the robots would automatically restart swinging. So we were quite happy with this experience, but it was before we didn't knew at all if it would actually work or not.
And so since that we started working with robots, there is one field that we tried to stay away until last year. In that robots have been used, maybe the only major way that they have been used in creative industries is in the film industry. Robots have been used since about 10, 15 years to control cameras on film productions, because usually when you want to move a camera, you put it on a dolly, which is like just something with wheels, and you just push it. So you can make your camera move forward, backward, or a bit higher with a crane, but you still do very simple movements. With a robot, you can do simple movements, but you can also make it fly completely freely in space. And so we knew that that was a way to apply our knowledge, but we didn't want this to suck our energy too early. So we stayed a bit away, and last year we were asked to make an advertising for a shoe company in Switzerland called On, and they said it was with Roger Federer, so we thought that maybe we should still start to work a bit on this. So that was us actually. When we bought the very first robot, we did one thing with a friend, and then we kind of put this in the back burner for a few years. But then we realized, okay, maybe we can use our robots to program them with cameras and program them in 3D, and then we can reproduce this exact movement. Yeah, and then we can reproduce this movement exactly in the physical world. And so this is something that we find very interesting with robots, is that the fact that they can move exactly from the digital space to the physical space means that they become a bit of a bridge between the virtual and the physical. And this is something that is really fascinating, because that means that we can do things yeah, in 3D, and then suddenly it happens in real life. Is there sound? Maybe? Is there sound? No? Okay. Okay, doesn't matter. But yeah, look, so these were some early experiments. So the robots were still visible. We had some ideas that maybe we would remove them, but it's actually the moment you realize an editor costs a lot of money. So we just did some cheap experiments for fun with a friend. But then this grew into higher production. So this was this ad that we programmed the whole robot to do all the sequence. So yeah, when you fly a camera next to the face of Roger Federer, you crap your pants a bit. But But that was really interesting. So this was 1 year ago, and since then we've been a bit starting seriously to move into film. So it's kind of becoming a side business of AATB that we call superposition. And then we've been doing more and more challenging jobs, mostly in Switzerland, and now we also started working in France. That's the robot next to Roger in the studio, and we also did a movie for the Most Beautiful Swiss Books exhibition, entirely shot with one of our robots. So yeah, I'm not going to leave the whole thing, but this is the kind of movement you cannot do with just a simple push cart. And so what is interesting is that the robots that you have seen, the orange ones, these are kind of part of the old generations of robots. They are large industrial robots, and what is very important is that they are very dangerous. They are very big, they have a lot of force, and usually you should never be next to them when they are working, because if there is anything wrong, they will cut you in half and continue happily doing what they do. So it's not very practical for experimentation, let's say, or to bring them in a studio or to bring them on set. And so the nice thing that has really kickstarted a lot of our research is the smaller ones you saw that are a bit gray, like shiny aluminum and with these blue edges. This is the one we are using for the workshop, and these are called collaborative robots. And the major thing is that these are much more safe because they have been thought from the start to be next to humans, initially in factory environments. So you don't need to fence them off. They have sensors, so if they hit something, they will stop, which means that we can very easily bring them in situations where you would never think about having a robot. And what we notice is that in the film industry, they have been mostly using these big robots, which means most of the film industry has been never putting these tiny robots in places like this. So at least in Switzerland now, it's quite interesting for us because we are developing new films with friends that just have not been experimented with before, and it's kind of creating and developing a whole new visual language also, because it's something that has been limited usually to Hollywood production, but now these robots are becoming much more cheaper and accessible, and so it reaches a new market, let's say. This was the setup that we brought in the studio, in the exhibition. So the robot was upside down, filming above the table. And we can finish with this one. Sadly, there is no sound, so you can't hear the music. But we filmed a whole music clip for a rapper in Zurich called Lil Bruzy. And the car had the robot on the roof and then the robot inside of the car. And the entire movie was shot with our robot. So this is the stage that we call the previs stage, the previsualization. And we worked out of a very terrible 3D scan of the car, but it was good enough that we could have a very good sense of the scale of things and where things were, where's the window, how do we can enter the car, where can we film. And from this, we programmed the entire music clip in 3D like this. And then from this, we go and export the program for the robot, and we end up with an actual film. So yeah, there's no sound, so it's going to be a bit bizarrely boring, but you can ask questions in the meantime. It's nice to hear people laughing after a year and a half of Zoom lectures. And what was interesting is that we did these movements where the movement from the outside, when it enters the window, is the exact same motion as the robot inside the car when it starts to enter and move in the car. So we could do this impossible shots where the camera seems to be, well, not exactly right here, but you will see it later, where the camera seems to be smoothly coming from inside the car to exiting out of the car, because the camera is like exactly placed in the same position. So we can do like coming outside of the car and then continues to film outside. And so it's really interesting for us that it's a whole new way of thinking about film and what you can do with the way you can tell stories. And this is something that now we are developing in Switzerland mostly. So that's it. Yes, it's 19. It's 19 individual shots, and we blend the two shots every time there are edges of the window. So every time the camera seems to enter the car, we always have kind of a movement where we can blend with the shot from the inside, and it overlaps. So the camera when it enters the car and the camera when it's a bit out of the car coming in, then we could blend this in post-production. Yeah, and we've been using this technique more and more on other shots also. Like actually the Roger Federer ad is 7 individual shots, and we had to reposition Roger 7 times to film every moment of the spiral we needed, and then this was all compiled as one trajectory. And this is something that is really fascinating with robots, because the robot can go perfectly in different places in space, and you can go back to there as many times as you want. So if you want the camera to be perfectly in space and then continue another shot from this exact same position, you can totally do this. And so it's creating new workflows that are just unthinkable if you are not working with this. It's a bit like having a way of digitally working in physical space. I mean, I don't know how to better say it. It's just a new way of thinking how to position the camera. But okay, yeah. It's a very cool song, by the way. Yeah. Thank you. We don't have to watch it again twice if you want to leave. The car was really driving around Zurich with a robot on top moving. It was a bit scary to leave the robot living with them driving. but it was really funny. Thanks. By the way, if you have questions, we are also happy to reply. Yes? It goes from free on Anibis to, or like eBay, to 150,000 for the big ones. But generally, it's between. The thing is, like, brand new, it costs a ton of money, but then there is a huge second-hand market where you can have one of the very, very big orange one. In the intro where we were the two of us with the big one, this was 10,000 euros. And so it's kind of something you can buy as an independent studio if you buy some equipment for woodworking or something. It's on this scale. So it's not a hobby machine, but then if you're a professional designer, it's completely something that is accessible. Mm-hmm. Yeah, the thing is, what is for us really interesting is the logic of a factory, and the logic of how you manage a production line is completely different from an independent designer, the way you think. You think in terms of, I'm going to buy a tool and I'm going to use it all my life until it's broken. The factory thinks, I have 50 robots on this production line, and in 2 years, they are not reliable enough, but I don't want my factory to turn off for 2 days because I have to change a robot. So I change all the robots every 2 years, even if they are still perfectly fine. So that's why you have a very interesting second-hand market where factory rather switch all the robots very regularly rather than have the whole thing turn down, like literally a minute in the factory. Like a car factory turning off for 1 minute is like millions they lose every minute, because to shut down everything and turn on everything is enormous. So they can't take the risk. So you end up with these machines that are perfectly fine, and they cost almost nothing anymore because they have been used. So then that creates this secondary market where, as a designer, you don't care if it might be, or like the lifespan of a robot, like the stated manufacturer lifespan is 40,000 hours between maintenance. 40,000 hours is 3 years, 24/7, doing the same thing super fast. And this is then it's not fit for a factory anymore, but it's still fit for you for 20 years probably, because you will be using it maybe a few hours per week, and that's literally, you will use 10% of the lifetime it could have over your entire career. And so that's also why there's a big opportunity for this. But there's now a market of a lot of cheap robots that are really good, but no big business wants to have them because it's not reliable enough. But it's more about people in looking at spreadsheets thinking that now this is too much risk, so we should switch all the robots. But for you, it might be completely fine, or for us.